Digital feels easy. Analog fights back. At first glance, analog and digital might seem pretty similar. They both use voltages, they both run on circuits, but one of them is way less forgiving than the other. Let's break it down. Digital systems live in a simple black and white world. There are only two states, 0 and 1. If a voltage is high enough, a logic gate sees it as a 1. If it's low enough, it's a 0. The space in between, that's the don't care region. A little bit of electrical noise or a small voltage ripple usually gets ignored as long as it doesn't cross that critical threshold. It's like a light switch, it's either on or it's off. There's no ambiguity. Now, let's step into the analog world. Here, there are no simple ones or zeros. Analog has no such luxury. In an analog circuit, every tiny change, every subtle variation matters. That 1 millivolt of noise from a power supply, it gets added to your signal. That 1 degree of temperature change that makes a resistor drift just a tiny bit, it affects the output, one component that isn't perfectly manufactured to its exact specification. You'll see it. Analog circuits don't ask, is this a 1 or a 0? They ask, exactly what is the voltage right now? And that answer is a moving target. It's a continuous, flowing river of information, not a set of neat, discrete steps. And then there's noise. Oh, the noise. In analog, you fight a constant battle against it. There's thermal noise, which is the random jiggling of electrons in every component. There's power supply noise, there's electromagnetic interference, or EMI, from nearby circuits radiating energy. Even the physical layout of the printed circuit board, the PCB itself, becomes part of the circuit. The traces aren't just wires. They have inductance and capacitance that can change how everything behaves. In digital design, timing is often the biggest headache. In analog, everything matters. The amplitude, the phase, the impedance, the physical layout, the grounding strategy, the temperature, everything is interconnected. There are no safe margins called logic levels. There are only endless trade-offs. You might filter out some noise, but that could affect your signal's speed. You might increase gain, but that could introduce instability. This is why analog design is often described as a dark art. It relies less on pure code and logic and more on physics, deep intuition, and years of hard-won experience. But when you build it in the real world, a true analog circuit always has a few surprises up its sleeve. Digital forgives mistakes. Analog exposes them.